welcome. Today we solve this question and it is from WASSCE June 2015 question 3, and it says that if the second derivative of a function is 2 here, so we see the second derivative of the function 2 here if it is 2, and the first derivative of the function, if you put in 1 you get 0, and if you put 0 into the function you get -8. Then we are asked to find the function. Now that is an example of what we call integration. So there is integration and the calculus, and I just want to say something small here. We have integration and we have differentiation. So let's look at basically what these two mean. Now if you have a function like say f of x, if you have a function f of x and you differentiate this function, if you're asked to differentiate and you differentiate this function, you have f prime of x. So the f prime, the one that you see here, the f prime that you see here, just f prime means first derivative. All right, so what we see here is called the first derivative. Okay, so when I go on to differentiate f prime of x, I get the second derivative, and that is f prime prime of x. So this one that we see here too is called the second derivative. Now if I'm asked to differentiate this again and I go on to do that, I'll get the third derivative, and that is f prime 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 of x. So if I want to go back, that is from here, either from here to here or from anywhere to get the function here, then I have to integrate. I have to integrate back so that I will get the function here, and if I'm doing that, we call that integration. So that is going back. So if you look at the question that we have here, we have been given f prime prime of x to be 2. We have also been told that f prime of 1 is 0, and we are also told that if we put 0 into the function we get -8. So what is the function? We don't know the function, and what we have to do is to find f of x, that is the function here. So because we have derivatives, you know, starting from here, that is the f prime prime, we have the second derivative, then f prime we have the first derivative, and we have to find the function, that is f of x. What we have to do is to integrate the equations that we have been given, or to integrate the second derivative so that we come to the first, and when we integrate that we get a function. So if you look at what we have here, as I did say, when you differentiate f of x you get f prime of x. If you go on to differentiate f prime of x you get f prime prime of x. If you go on to differentiate f prime prime of x you get f prime 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 of x. It goes on like that. So if you look at the question, it has just the second derivative, and if I want to find a function when I'm given this, then I have to integrate this function, so that when I do that I will get f prime of x. So it will reduce from the prime prime to just 1, f prime, and you know, I don't want f prime, I want f of x, because it says find the value of f of x, that is find the function f of x. So I have to integrate f prime of x too, and when I do that I will get f of x. So that is what I have to do, and that's how the question will be solved. All right, so let us start and let's look at how we solve that. All right, so let me start by writing what we have here. First we are given f prime prime of x, so we have f prime prime of x, and that is equal to 2 here. So that is the first thing that we have here, and from here to we have f prime of 1 equals 0 and others. So let me also put that data down. So we also have f prime of x, which is equal to, f prime of 1 rather, we have f prime of 1, and that is equal to 0, and we are also giving f of 0, which is equal to -8. Okay, so we have these three equations to find an expression or function of f of x. So let me start from here. So that is what I'm going to do. I'll write the f prime prime of x, and of course this is equal to 2. And to find f of x, I have to integrate. I have to go back, and so I'm going to write integral of f prime prime of x with respect to x, and I have to do the same thing to the right hand side. I will integrate 2 with respect to x. So when I integrate f prime prime of x with respect to x, it will reduce the derivative, that is from the second to the first. So I'm going to get f prime of x here. And when I integrate 2, I'm going to get 2x. And after 2x, I have to add a constant of integration. So I will have 2x plus, all right, let me add a certain b here. Let me try to explain this before we go on. Now, what I'm trying to say is that under integration, if you have a constant, say, let's take for an instance, if you have, say, 3, and you're asked to integrate 3 with respect to x, the answer is 3x. But because there is an indefinite integral, what we mean by indefinite integral is that if you have an integration, there is something that we call the limit of integration. That is when you draw, draw the sign, we have some values that have to be here. There is a value here, and there should be a value up here to a constant here and there. That we find here is called the lower limits. So this value is called the lower limits, and the one that we have here is called the upper limit. Now when we have values here, we call this form of integration definite. So we call it definite integration because we know the limit. We know where we have to integrate from, that is from a to b. For an instance, you can have something like integrates, say, from negative 1 to 3 of say x squared plus x squared plus x plus 1 with respect to x. So there is a definite integral because we have the limit of integration here. It starts from negative 1 up to positive 3. So there is the lower limits and there is the upper limits. Now in an event where we don't have these values, we call it an indefinite integral. We call it indefinite integral. So when we're doing an indefinite integration example, is what we have here. If you have something like integral of just 2 with respect to x, because we don't have limits at these ends here, that is called an indefinite integration. And after integrating this, you have to add something that we call the constant of integration. So this will be something like 2x, and you add any constant. You can add, say, c, or if you want, you can use anything that you want to use here. You can use k, or in my case I want to use b, so you can also use, say, b here. All right, but first let us look at how to integrate. Now if you have any constant, any number, when you say a constant is a number, if you have any number, example the number, say, 4, and you're asked to integrate 4 with respect to x, because it is with respect to x, it means the function is made up of the independent variable x. Yes, because you are to integrate the number 4 with respect to x. So that means that the function is made up of x. So 4 is the same as the number, or is equivalent to 4x to the power 0. Now in math, or let me say indices, any number raised to the power 0 is 1. So 4 is the same as 4x raised to the power 0. So if you ask to integrate 4 with respect to x, it is equivalent to saying integrate 4x to the power 0 with respect to x. Now when we integrate, what we do is that we add 1 to the power. So we have 4x raised to the power 0 here. So if we are to integrate this, what we have to do is to add 1 to the power. So we have 0 plus 1, and that is 1, and we divide it by the one that we get here. Okay, And because there is an indefinite integration, right after that we add a constant of integration. You can add c, you can add b, a, anything here. In this case I want to use b, so I have something like this. So x raised to the power 0 plus 1 is 4x. Sorry, 4x raised to the power 0 plus 1 is 4x, because 0 plus 1 is 1. So I'm going to have 4x raised to the power 1, and I'll have b plus b here. And 4x to the power 1 is 4x. So I'm going to have 4x plus b. Alright, so that is the reason why that when you integrate 4, you get 4x. Excuse me, and you add the constant of integration. So let us look at some examples here too. All right, so example, if you are given this, integrate say 9 with respect to x, and that is going to be, because it is a constant and I'm integrating with respect to x, is going to be 9x, and because it is an indefinite integral, I'll add a constant of integration. Let me say b, just a b or a k or anything that you want to add here. Integrate say 100 with respect to x. 100 is a constant, it's just a number, so it's going to be, because it is with respect to x, it's going to be 100x, and I add a constant of integration, and I'm going to choose say b again. If you ask to integrate say half with respect to x, half is a number, it's a constant, there is no variable, so that is going to be half x. Add my constant of integration. In this case I'm going to use b. Okay, if you ask to integrate say let me take another fraction, say 7 out of 3 with respect to x, that is going to be 7 out of 3 x, then add a constant of integration. Yeah, so as you've guessed right, if I change the independent variable, for example, if I ask you to integrate say 10 this time around with respect to k, so I have integral of 10 dk. Here it was with respect to x, so we had 7 out of 3x. With respect to x, here we had half x. With respect to x, that is, we were asked to integrate 100 with respect to x, we had 100x. We were asked to integrate 9 with respect to x, we had 9x. So 10, integrate 10 with respect to k, that is the integral of 10. The k, that is of course going to be 10. Here is going to be k, then you add any constant of integration that you have to put here. So that is why we have this. So when we integrate 2, it is with respect to x, so we are going to have 2x, and because it is an indefinite integral, there are no limits. We don't have the lower limit, we don't have the upper limit here, so we are going to add the constant of integration. All right, let's go on here. So that is what we have at this point. We have integrated from the second derivative to the first, but we go back to our data. We look at this here. Here we are told that when we get a function for the first integral, when we put in the value 1, when x is 1, what we get is 0 here. So we will use the second equation. So what we're going to do is that we say that, but we know, so let me put it this way here, but we know that f prime, if we ought to put in 1, we get 0. That is from the second equation. So what we're going to do is that we are going to put in the 1 here. So when I write f prime of 1, it means that the value of x is 1, because if you look at it, if you compare this, you see that we have f prime here and we have f prime there, and f prime is a function of x here. So if there is 1 here, then that means x is equal to 1. So let me put it here. That is when x equals 1, x is 1, then we will have f prime of 1. That means that where we have x, we write 1. So wherever we see x now, there is what x here, so we will write 1 here, put in 1 plus b. Okay, so that's what we have, and let's go on from here. But we know that f prime of 1, the whole of this gives me 0, so the whole of f prime of 1 here will be 0 here. So I'm gonna have 0. Let me clean this so that people don't think that it's a division sign. Of course it's not. Here, let me clean this from here. Okay, so and 2 times 1, we know 2 times 1, right? 2 times 1 is 2, and plus b. All right, so we make b the subject, or we find b stands alone. So if I leave b here and send you to the other side of the equal sign, I have -2 here. So this implies that b equals -2. So I know the value of b is -2. And let me go on with my solution. All right, so if the value of b is -2, then I can write this. I can come back here and write that f prime of x equals 2x minus 2, because now I have found the value of b. The value of b is -2, so I can put it here. So I can write 2x minus 2 here. Now I have to find the function f of x, not f prime of x. So I'll go on to integrate here again. So what I'm gonna do is I will integrate f prime of x here, and once again I'll integrate this. Let me go to the next line so that I do that. So I'm going to write f prime of x here, and I'll integrate f prime of x with respect to x, and I have to integrate the whole of 2x minus 2 also with respect to x. All right, and when I do that, when I integrate f prime of x, I will now get the function f of x, and I'm going to integrate 2x minus 2, and of course it's an indefinite integral. So let me write it well so that we do it step by step. Now we have 2x here, and we have minus 2. But 2x, the power here is 1, okay? And I have said already that a constant, because the function is in terms of x, the constant too has a coefficient of x, and that coefficient is x raised to the power 0. Let me write that in blue so that we can see. So it's x raised to the power 0. So if I'm going to integrate this, I have to add 1 to the power here. I have 1 plus 1, that is 2, and I'll divide it by 2. And here too, I'll add 1 to this. 0 plus 1 is 1. I will divide by 1. And the last thing I will do is that because there is an indefinite integral, that is because I don't have limit here and there, see, I will add a certain constant of integration. Because here I used b here, I'll use a different one here because it is the same function that I'm dealing with. So I'm going to use another one, and this time around I'll use a c. Okay, so let me simplify this function. So f of x equals 2 here, 1, 2 there, 1. So x raised to the power 1 plus 1, and 1 plus 1 is 2. So I have x raised to the power 2 minus, and 0 plus 1 is 1. So I have 2x raised to the power 1, and that is 2x. And I have plus a certain c. All right, I've now got to the function that I want. The question says I have to find f of x, and I've found f of x. F of x is x squared minus 2x plus c. But the problem is that I don't know the constant of integration. That is the c, and I have to find the c. So that is the next thing I have to do. Oh, luckily for me here, I have another equation. That is in terms of the function itself. It says that when I put in 0, that is when I put x equals 0 into the function, I get -8. So let me write it down here. The third equation says that f of 0 gives -8. That means when I substitute 0 into x here, the final result is -8. And that means when the value of x is 0, the function evaluates to -8. That is when x equals 0, the function evaluates to -8. So I'm going to put in 0 here so that I can find my constant of integration c. So I'm going to write f of 0. Okay, and it means where I find x, I have to write 0 there. So 0, 0, and here to 0 plus c. But what is f of 0? Okay, it's very clear. F of 0 is -8. So that is -8 here. And the whole of this will be 0, this will be 0, and I will have a certain c here. So -8 is going to be c. Okay, so all this means c equals -8. All right, I think that is appropriate. Okay, so now I found this constant of integration. The function says f of x. Let me write over here. So this means f of x will now be equal to s squared minus 2x. Then the c is -8. So that is the function. The function is s squared minus 2x minus 8. And that is how we solve this question. Alternative approach. All right, I want us to look at another way that we can solve this question. All right. So alternatively, that is how we can solve this. Now, if you look at the question, it says that the second derivative of the function gives just a constant, a number. Now, if the second derivative of function gives a constant, just a number, then that function is a quadratic function. Yeah. Why am I saying this? Look at a quadratic function. A quadratic function is of the general form f of x equals ax squared plus bx plus c. Now, let me try to differentiate this function twice. If I do it for the first time, okay, I have to pull the 2 down here, so I'll have 2a, and I will subtract 1 from the power. I will have x raised to the power 1, and here is x raised to the power 1. I have to pull the 1 down here. 1 times b is b, and I will subtract 1 from 1. I will have 0, so I will have bx raised to the power 0. And when you differentiate a constant, you get 0. It is very simple, because c, I've said that any constant has a coefficient of the independent variable raised to the power 0. So c is the same as cx raised to the power 0. So if I have to differentiate, I will pull the 0 down, so I'll have 0 times cx, and I'll have to subtract 1 from this, but the whole of this times 0 gives 0. So let us put this at the back of our mind, that when you differentiate a constant, you get 0. Okay, so here the whole of this is going to be 0. So we will have f prime of x, that is the first derivative, as 2ax plus b. It is b because x raised to the power 0 is 1. Now let me go on to differentiate f prime of x. So I'll have f prime prime of x, that is the second derivative, and here is 1, right? If you pull the 1 down here, 1 times 2a, you have 2a. If you subtract 1 from 1, you have 1 minus 1, and that is x raised to the power 0. And here too, b is a constant. If you differentiate b, of course, like this, you will have 0, because b is equivalent to bx raised to the power 0. So if you pull the 0 down, you have 0 times bx, and if you subtract 1 from this, the whole of this times 0 gives 0. So the whole of this is 0. So eventually we will have the second derivative of the function to be 2a. Yes, it is 2a because x raised to the power 0 is 1, and 2a is a constant. It is a constant because we don't have any x variable here. So what I'm trying to say here is that anytime that the second derivative of a function is a constant, then that function is a quadratic function. All right, let me write something down here. So since the second derivative is a constant, it implies that f of x, that is the function, is quadratic, or is a quadratic function. So let me put it this way. So it means that it is a quadratic function. So if I'm going to solve such a thing, I will first say that let's the function, I don't know the function, I'm to find a function, but I know that the function is a quadratic function. So I'll say let's the function, that is f of x, let it be equal to the general quadratic function, that is ax squared plus bx plus c. So my job here is to find the constant a, b, and c. All right, so I start right away. You know, if you look at the first one that I solved, I began from the f prime prime, integrated, and I had the f of x. This time around, because I am saying that let the function be f of x, I'll rather start from the f of x. I'm finding the function here, but if I look at what I've been given, I was told that the first thing that if I put 0 into the function, I get negative 8. That is the third equation that we see over here in the question. So right now I'm saying that let a function be ax squared plus bx plus c. So I can put in 0. So this means that when x equals 0, that is what I'm going to have here. I'm going to have f of 0 equals a. So wherever I see x, I have to put 0 there. So b, 0 here, then plus c. So I'm going to get f of 0, but f of 0 equals negative 8. So I'll put negative 8 here. Oh, come on. Let me write it well. Okay, that is better. The whole of this will be 0. This will be 0. So I'll have c. So this implies c equals negative 8. If you remember the first one that I just solved, we had the c to be negative 8. That is the last, the third term or the last term. We had it to be negative 8. Now let's go on. Now, so we have used the third equation, that is f of 0 equals negative 8. Let's get to the second one. To get to the second one, we have to differentiate f of x. So that is what we're going to do. We know f of x is ax squared. Now we know c, so we can even put in the c, ax squared plus bx, and c now is known. C is negative 8, so let us put c there, negative 8. Now if we are going to use the second equation, then we have to differentiate the function. So f prime of x, so we pull the 2 down here, and we have 2a, and we will subtract 1 from the 2. You have x raised to the power 1 plus, then here too it is bx to the power 1, so we pull the 1 down here. Then we have 1 times b is b. We subtract 1 from 1, we have x raised to the power 0. Negative 8 is a constant, so that will resolve to 0. Okay, so f prime of x is going to be 2ax plus b, because any number raised to the power 0 is 1. Now we have this first derivative function, and because we have this equation here, that is f prime of 1 equals 0. Let me write it down here for reference. But f prime of 1 equals 0. So that means when the value of x is 1, the function evaluates to 0. So when x equals 1, that is what we're going to have. So you have f prime of 1 equals 2a, where x is 1, so we put 1 there, we have plus b. All right, and when we put f prime of 1, when we put 1 into the f prime of x, we get 0 here. All right, so let me go on from here. So f prime of 1 here equals 0, so that means the whole of this will be 0 here. Then 2a times 1, we have 2a, then we have our b2. So we get our first equation here in terms of a and b. Okay, let's see if we can go on to solve the second, or to use the second, the third equation, that is f prime prime of x. So from here, let us differentiate the function again. So we have f prime prime of x, and when we do that, what is the f prime? Where is the f prime? Yes, the f prime is here. There's the f prime of x. So from here we are having f prime prime of x. So what we have to do is x is to the power 1, so we pull the 1 down here, so we have 2a times 1, and that will be 2a. If we subtract 1 from the power x, we have x raised to the power 0, and b is a constant, so when we differentiate b, we have 0 here. Okay, so what we're going to have is f prime prime of x is going to be 2a, because x raised to the power 0 is 1, and that is also 0. All right, so f prime prime of the function x is 2a. But what do we have from the third equation, that is the f prime prime of x equals 1? Let's see. Now, but we know that f prime prime of x according to the equation equals 2. So the whole of this is f prime prime. And here we also had that f prime prime of x equals 2a. So what does it tell you about the value of a? Well, the value of a is 1. Why? The value of a is 1 because, we had f prime prime of x to be equal to 2a, right? But from the question, we were given that f prime prime of x equals 2. So that means where we have f prime prime of x, we write 2 there. So we have 2 equals 2a. And if we have 2 equals 2a and we want to find the value of a, we have to divide both sides by the coefficient of a. So that gives a to be 1. So if you look at what we have here, we now know the value of a to be 1. The value of b, where is it? All right, the value of b is not found yet, but we know the value of c to be -8. So we have to find the value of b. But luckily, we have an equation that links a to b. So we say puts a equals 1 into, let me give a name to this equation so that I can reference it easily. So let me call this equation 1. So you put it into equation 1. And from equation 1, that is what we have. We have 2a plus b equals 0. So this means where we have the a, we put 1 there. So that means 2, a is 1 plus b equals 0. And 2 times 1 is 2 plus b equals 0. So b will be equal to -2. And that brings us to the end of the constants. Finding the constant. So we have a here, we now know b, and we know c. So we get back to what I first wrote here. I said let's the function that we're finding to be ax squared plus bx plus c. Now I have found a, I have found b, and I know c. So therefore the function f of x equals a is 1, so I'll have 1 x squared. So plus b, but b is -2, so I'll have something like plus -2. So it's going to be plus then -2 x, and the last one is c. So I have plus c, and c is -8. So I have plus -8 here. So plus -8. All right, so the function f of x will be s squared here, because 1s squared is s squared, and plus -2 will be -2x, and plus -8 will be -8. So this is the function, that is s squared minus 2x minus 8. And that is how we can also solve this question. Thank you.